Hi, everyone. Let's get started with our Evaluate review for this month's Math Evaluate test. If you don't have a paper and pencil handy, grab that now so that we can get started with our review. Our first few questions are all about geometry and geometry concepts. Before I give you a question to answer, let's review these two terms. The first one on your left is parallel. This comes straight out of your Math SRB book. For parallel, the book says, parallel is always the same distance apart and never meeting or crossing each other, no matter how far extended. Line segments are parallel if they are parts of lines that are parallel. The bases of a prism are parallel. Take a look at the pictures that they are showing you. When they're talking about the bases, they're talking about the bottom and the top. Those are parallel bases. Or as they show on the right, it kind of looks like the left and the right. Those are parallel. They're the exact same distance apart. Remember, parallel lines, they never cross or touch, no matter how far they are extended. And perpendicular lines are almost the exact opposite. Our SRB says, for perpendicular, being part of two lines that cross or meet at right angles. The symbol that looks kind of like an upside down T means it is perpendicular to something. So if you take a look at the picture, the first one shows two lines that are crossing, and when they cross, they make a 90-degree or right angle. Every place where those lines cross form a 90-degree angle. Underneath the lines are examples of perpendicular planes. When those two planes meet each other, they form a 90-degree angle. Same thing is true for rays. No matter where they cross, whether it's here at the edges or in the middle, they can form to make a shape that might look like a T or even an L. The key is when they cross, they form a right angle. So hopefully that'll help you on the next few questions so that you can remember the difference between parallel and perpendicular. This picture is going to help you answer questions 1 and 2 on the Google form below. The directions say drag the appropriate set or sets of lines into the box or boxes that describe them. The way I set this up is I've made the pairs or sets of lines labeled with numbers. So we have pair A first, pair B, pair C, down at the bottom, pair D, and then finally pair E. Now, you don't have the dragging ability on this video, and neither do I. But in the question, I will ask you to tell me which sets of lines are perpendicular. And you might say sets A and B. And then in the next question, I'm going to ask you to refer back to this slide and tell me what sets of lines are parallel. And you might say C, D, and E. So when I ask you to answer questions 1 and 2, you'll be referring back to this slide. So let's do that now. I want you to pause your video, find question 1, and tell what sets of lines are perpendicular. Then find question number 2 and tell which sets of lines from this slide are considered parallel. Once you've answered question 1 and question 2, I want you to come back to the video and press play to move on to the next 2 questions. Questions 3 and 4 on our review still are about geometry. This time we're talking about perpendicular and parallel lines again, but now we're talking about those lines within a shape. For question number 3, you're supposed to look here at this purple box. It says, does not need to have perpendicular lines. So you're going to tell me all the shapes from the bottom that does not need to have perpendicular lines. Which shapes do not need to have perpendicular lines? Remember what perpendicular means from the very first slide. Then question 4 is going to be related to this orangey peach colored box. This one says, does not need to have parallel lines. So you'll go down here to the bottom. Oops, I'm sorry. Let me flip that back. You'll go down here to the bottom and you will decide which shapes from here in the bottom, A, B, C, D, E, would fit into this orange box. Which shapes do not need to have parallel lines? So pause your video now, find question number 3, and tell which shapes from the bottom do not need to have perpendicular lines. Then go to question 4 and tell me the shapes that do not need to have parallel lines. Remember, the names of the shape will be labeled A, B, C, D, and E in your question choices. Once you've answered question number 3 and question number 4, turn your video back on to move on to question number 5. Question number 5 is our last geometry question from this review. Question number 5 says, select the shapes below that have at least one pair of perpendicular sides. I gave you that picture and description of what it means for things to be perpendicular. There are some pictures to look at to help you remember. So you need to tell which shapes, and there's probably more than one, that have at least one pair of perpendicular sides. Which shapes have at least one pair of perpendicular sides? On this question, you're going to need to type the names of the shapes so that you can type more than one of these answer choices. You can type the name of the shape, then put a comma, and type the name of the next shape that has to have at least one pair of perpendicular sides. Just make sure to put commas between the names of your shapes. Pause your video now, find question number 5 in the Google form, and tell me which of these shapes, a trapezoid, a square, a circle, an acute triangle, or a right triangle, which ones of those listed shapes have to have at least one pair of perpendicular sides? And remember, when it says at least, that means they could have more, but it's not required. Once you've answered question number 5, I'll want you to turn your video back on and we'll move on to question number 6. Question number 6 is a problem that we've looked at before. Question number 6 says, write 9 as a fraction in lowest terms. Remember, we said when the denominator and the numerator of a fraction are the same, they're equal to 1. Doesn't matter what the number is. It can be 2 over 2. It can be 50 over 50. When the numerator and denominator are the same, they're equal to 1. But then think about, how do you make a number that's bigger than 1 in fractions? How would you write 9 as a fraction? Then think about it in lowest terms. Think about how small can you make the denominator and still have the numerator be 9. Pause your video now, find question 6 in your form, and pick the fraction that shows 9 in lowest terms. Once you've picked your answer, turn your video back on and we'll go on to number 7. Question number 7 says, enter the correct numbers to complete the statement. Well, this is one of those questions that would have a drop down. This would be your answer, and this would be your remainder. The question says, when 2,924 is divided by 6, the quotient is blank with blank, and that would be your remainder. It would say like with a remainder of 0 or a remainder of 4. We don't have the option to do a drop down on a Google form. So what you're going to do is solve this problem on your paper. On your paper, you should write 2,924 underneath the table, then 6 as the divisor out to the side. Solve the problem, and then tell us the quotient is your answer with a remainder. So tell me the answer with a remainder if it has one. Pause your video now to solve that problem. Then find question number 7 in your Google form and answer it. Then when you're done, turn the video back on and we'll move on to question number 8. Question number 8 says, Jace rode his bike for 85 minutes on Friday. On Saturday, he rode his bike for 175 minutes. On Sunday, he rode his bike for 193 minutes. How much time has Jace spent riding his bike in these 3 days? When I first read this problem, I thought, so easy. I can't believe people got this one wrong. It's just 3 numbers for the 3 different days that he rode his bike, and you just add them up for the total number of minutes. The tricky part is when you go down to find the answer has been converted from minutes to hours and minutes. When you add up 85 plus 175 plus 193, you're going to get a large number, but it's just going to be in minutes. What you have to do is convert that to hours, and then there'll be some minutes left over. I put a key here on this slide to help you remember that 60 minutes is equal to 1 hour, 120 minutes is equal to 2 hours, and then so on all the way down to 7 hours. So you need to add those 3 numbers, find out how many minutes that is total, and then convert that to hours and minutes. So pause your video now, solve this problem, then go to your Google form, find question number 8, and fill in the answer there. Once you're done with your answer for question number 8, restart the video and we'll move on. The next question is going to be question 7 on your Google form. It says Valerie has the following subtraction problem. 6,832 minus 4,296. Well, that doesn't sound too bad. They're big numbers, but we know how to subtract. The next part of the question says Valerie believes the difference, or the answer, is 1,612. How far off is her guess from the correct answer? The correct difference. So this is telling you right now she's off because they said how far off is her guess. So the answer that Valerie came up with, 1,612, they're telling you that is wrong. So you have to find the correct answer when you subtract 6,832 minus 4,296. Then you have to find the difference from the correct answer and Valerie's answer. You need to find the difference between the 2 answers. So pause your video now, solve this problem, Then find the difference between the correct answer and Valerie's answer. Then go to question number 7 on your Google form and enter the correct answer there. Once you've answered question number 7, turn your video back on and we'll move on to the next question. All right, we're ready for question number 8, and this is our final question for today's Math Evaluate review. Question 8 is a story problem. It says Carl's rectangular vegetable garden is 20 feet by 45 feet. McKenna's garden is 25 feet by 40 feet. How much larger is McKenna's garden than Carl's? I've already done the cubes process for you on this problem by circling the numbers, underlining the question, and boxing in the clue words. Those clue words that say how much larger tell us we need to subtract. But before we can do the subtracting, we have to multiply because they tell us the dimensions of the two gardens. Here's Carl's on the left and McKenna's on the right. What they don't tell us is the area. They want us to decide how much larger is McKenna's. So they're saying McKenna's is larger, how much larger? And the way to do that is to find the area. So you have to find the area for Carl's garden and the area for McKenna's garden. Then the how much more means you need to subtract. Subtract the area of McKenna's garden from the area of Carl's garden. And that will give you the answer to question number 8. So pause your video now. Find the area of Carl's garden on your paper. Find the area of McKenna's garden. Then find out how much larger is McKenna's garden than Carl's. Then find question number 8 on your Google form and fill in your answer choice there. Once you have answered question number 8, you are done with today's Math Evaluate review.